Hello, welcome back. In this segment we're going to look at some of the operators in the C language that we haven't considered up to this time. First of all, the logical operators. These are and, or, and not. And they come in two flavors. The and the or come in short circuit and not short circuit. And we'll look at what those mean. We're also going to look at some compound operators in the C language, the compound assignment operator and the increment and decrement operators. So there isn't much coding in this segment. There's only a look at operators and understanding how they work, and you'll be expected to be able to use these in the next segment. So let's go and have a look at the slides that demonstrate how these operators work. First, let's consider the logical operators. In C there are three: and, or, and not. We use these words in English as well. For example, in the sentence, I will eat lunch if it's noon and I'm hungry. In that case, in order for me to eat lunch, both those conditions have to be true. It's noon and I'm hungry. In the next example, I'll eat lunch if it's noon or I'm hungry. So in that situation, only one or the other has to be true. So we use these logical operators in English as well as in formal languages like C. In English, however, we very often don't use them correctly. I was in a meeting once where the speaker said, "Everyone stand up if you were born before 1960 and after 1990. And certainly all of the younger people and all of the older people in the room stood up. No one was born before 1960 and after 1990. The speaker certainly meant or, but in English everyone knew what was intended. And when you express something in formal logic, you have to express exactly what you intend, or it isn't going to have the intended result. So in C, the logical operators, and, or, and not, are represented using these ampersands and the vertical bars, and the not is an exclamation point. So here's our first example of an expression that evaluates to true or false using logical and. So we write if A is greater than B and C is equal to 10. So we do the relational parts first. A is greater than B, and that will evaluate to true or false, and C is equal to 10, and that will evaluate to true or false, and then we AND them together. So if we had true and true, then the whole expression would evaluate to true. If either of these were false, then the whole expression would evaluate to false. So go back up to this one. If it's noon and I'm hungry, both of those, noon and I'm hungry, had to evaluate to true in order for this to evaluate to true. And similarly in formal logic, with and, both of them have to be true. So what are all the possible combinations of true and false that we can combine using these logical operators? These are called the truth tables. The top one here is the and truth table. True and true is true. Any other combination of true and false evaluates to false. Here's the or truth table. True or true is true. True or false is true. False or true is true. And the only case is where the result would be false is when we have false or false, because neither of these are true. The truth table for the not operator is very simple. Not true is false and not false is true. We have to look at the rules of precedence now. We have relational and logical operators being combined into one expression. Let's look at this expression now. We'll do the relational operators first. So I don't know what's in A, B, C, and D, but let's assume that A is greater than B evaluates to true, C is equal to D is false, A is less than D is false. So we do the relational operators first, and then we would say true or false and false. How do we evaluate that? This is where English completely fails, because no one knows how to evaluate this when you have an and an or in one English sentence. In formal logic, the and operator has the higher precedence, so we're going to evaluate the and first. So we'll say false and false is false, and then we have true or false, and we evaluate that to be true. So the and operator has the higher precedence, higher than or. If you do that in the wrong order, if you do it from left to right, you will get the wrong answer. But most combinations of true and false, you get the same answer anyway, but not for the reason that you intend. Sometimes in English this completely fails. When we're making the prerequisites for the courses, sometimes we'll write down, you have to have this course or that course and that course. And it's impossible for anyone to read it and know exactly what it means. Well, it's possible if the person who's reading it happens to understand formal logic and the person who was writing it happens to understand formal logic, but that's almost never the case. And in English you can't use parentheses to make it more clear. The unary operator not, unary meaning that the not operator has only one operand and it's on its right, it has the highest precedence. So the unary operators in C have higher precedence than binary operators. The unary not has a higher precedence than the relationals. So that makes the rules of precedence just a little bit more complicated. You do the not, then the relationals, then the and then the or. Let's consider now the true and false values in C. Although some languages have a data type to represent true and false, C does not. C uses numeric values for true and false, and in C the value 0 is false, and anything that's non-zero is true. So we could have a statement that doesn't seem to make any sense, if 15. And in C that's a correct statement, because 15 is non-zero and it's true. When we write a relational expression, like 10 is greater than 5, we've been saying up until now it evaluates to true, and in C what that really means is it evaluates to 1. 10 is less than 5 evaluates to false, and in reality what's going on internally is that it evaluates to 0, and 0 is considered to be false. Let's look at some examples of expressions that use relationals and logicals. So in this first one, A is less than or equal to B, or C is greater than or equal to 4. What will we do first? Well, we're going to do the relationals, less than or equal to and greater than or equal to. So A is less than or equal to B. What do we have there? 10 is less than or equal to 6. That's false. And on the right hand side, C is greater than or equal to 4. That's true. So we have false or true. Is the whole thing true or false? The whole thing is true. If you remember in the truth tables, this is false or true is true. Now we have a not operator, and you'll most commonly see the not operator written before something with parentheses around it. If the parentheses were not here, we would have not 10, which would be 0. So with the parentheses, we're going to do the relational first because it's inside the parentheses. So A10 is greater than B6. 10 is greater than 6. That's true. What's not true is false. So this whole expression, including the not operator, evaluates to false. In the next one, B is equal to C. 6 is equal to 4. That's false. Not false is true. True and B is greater than or equal to A. 6 is greater than or equal to 10 is false. And in the next one we have the situation where we have an or and an and in the same expression. So we're going to do the relationals first, then the and then the or. So here are the answers for these ones. I would encourage you to go through these on paper and make sure that you're getting the same answers as what I'm showing here on the slides. Here is one of the pitfalls that all C programmers will eventually fall into. The single equals sign in C is the assignment operator, and we're pronouncing that gets so that we won't confuse it with the relational operator equals. If you do accidentally write if A gets B, would that evaluate to true or false? Well, an assignment statement evaluates to the value that goes across the assignment. So 6 is assigned to A, and this expression A gets B evaluates to 6. 6 is non-zero, which is true. So this is a very difficult bug for you to see. When you look at it, you see what you want it to be instead of what's actually there because of this gets versus equals operators that are so similar. And the second pitfall we already talked about on the previous slide. It's the precedence problem that you might not be expecting. Not A is less than B. You might be intending not A is less than B, but what's actually going to execute is not 10, which is 0, and 0 is less than 6 is true. So this last line is almost certainly what was intended there, not the result of A is less than B. So the parentheses are used to force the relational operator to happen before the unary operator not. Here are some practice exercises. What I would like you to do is to work these out on a piece of paper. So pause now, work them on a piece of paper, and then go into the development environment and write some if statements. So you can do them one at a time. Write an if statement and just output a printf. Use a printf and say it's true or it's false, and make sure that your answer on paper corresponds to the answer that the machine is getting, and then you will be convinced that you can manipulate expressions that are using the relational and the logical operators. I'm not giving you the answers to these ones. The machine will give them to you when you execute a C program. In the introduction to this segment, we talked about the two different kinds of and or operators, and we're going to describe that now. It's the short circuit behavior. There are actually two different and operators, the one with this 2 keystrokes, 2 ampersands, and then the 1 ampersand. We've been using the 2 ampersands and the 2 vertical bars for the OR operator, and logically this AND is the same as this AND. So what's the difference between them? Well, let's look at an example to understand it. 10 is greater than 20. Is that true or false? Well, it's false. Now we have false and something else. False and anything is going to be false. So we already know the answer when we've evaluated only the left-hand side. Why should we evaluate the right-hand side? And using the 2 ampersands, we don't. This is called a short-circuit behavior. So for efficiency, we're not going to evaluate the right-hand side if we already know the answer. So false and anything is false. Conversely, 10 is less than 20 is true. True or anything is true. So just to review, if we have false on the left of an AND, then we don't need to evaluate the right-hand side. If we have true on the left-hand side of an OR, we don't have to evaluate the right-hand side. If you use these single keystroke operators, the single ampersand and single vertical bar, then both sides will be evaluated without short-circuiting. So that's the difference between the double ampersand and the single ampersand. We don't have to evaluate the right-hand side using the double ampersand. Okay, now we're going to consider the compound assignment operators. The language doesn't really need these. It doesn't add anything that you couldn't have done in a longer form. It's just a shortcut form for some of the operators that we've already looked at. So look at this one, for example. Total gets total plus amount. This is very common. We're going to add an amount into total and put it back in the same variable. So now we have a new operator. We're going to read this plus gets, and we can say total plus gets amount. That means take amount and put it into the total, add it to what was already there. So you should be using these compound assignment operators when you have the opportunity to do it. On this list of the compound assignment operators, I see that I put multiply gets twice. There are only 5 corresponding to the 5 arithmetic operators: plus, minus, multiply, divide, and modulus. So here's another example of plus gets, and here's an example of multiply gets. So this is a short form of factorial gets factorial times number. And there's not too much tricky about these. The only one that I can think of is when you have a multiplicative compound assignment and an additive operator on the right hand side. Which happens first, the addition or the multiply? Well, the compound assignment operator has the same precedence as the assignment. That means the lowest possible precedence. So it's going to happen last. When you expand this particular one, we're going to expand it to A gets A times, and then in parentheses B plus C. So what happens, what is on the right of the assignment is going to happen first, and then the assignment operator, including the arithmetic part of the assignment operator. In this case, A times whatever is on the right of the assignment. Okay, 2 more operators and then we'll be done. The increment and the decrement operators. Suppose we want to add 1 to a variable. This is a very common thing to do with a counter variable, and we could write count gets count plus 1. And now that we have compound assignment operators, we could write count plus gets 1. But this is so common that there's even a shorter form in C. We can write plus plus. So count plus plus means add 1 to the variable count. And there is a corresponding decrement operator, minus minus, which means subtract or decrement the variable by 1. These increment and decrement operators come in 2 flavors. It depends on where the operator is. If the operator is after the variable, this is called a post-increment operator. And if it comes before the variable, it's called a pre-increment operator. And the position of the operator impacts when the increment will happen. So the post-increment will happen after something, and the pre-increment will happen before something. Well, before and after what? It's before and after everything else in the statement. In this particular example, there isn't anything else in the statement. Count plus plus and plus plus count are exactly the same because there's nothing else there to be before or after. So let's look at a more interesting example. B gets A plus plus. This is a post increment. So the variable A has 10 in it, and when we say A plus plus, when does the A become 11? It becomes 11 after everything else, including the assignment. So B gets the value 10, and then A becomes the value 11. This is quite different behavior from the one on the right, which is a pre-increment. Plus plus A means add 1 to A, it becomes 11, and then assign that to B. So the increment operators and decrement operators kind of break the rules of precedence. They can come before or after everything else, including multiplicative operators. You have to be a little bit careful with these. You can mix them in with other operators. So in this while loop, for example, plus plus count is less than or equal to 5. What happens first? What gets compared to what? Well, this is a pre-increment, so we would add 1 to the count and then compare it to 5. So these should be used sparingly. They can make your code a little bit shorter, but they can also make your code more complicated. Our goal is to write code that's efficient and clear. Clear is probably more important now than it used to be because the machines are so incredibly fast. So use these sparingly. If you have something that starts to get complex and you have to think too hard about it, then you might want to put it on separate lines of code, rethink the approach to solving the problem. Okay, let's summarize what we've done in this segment. We looked at the logical operators in C, and, or, and not, and the short circuit behavior of the and the or, depending on how the left-hand side evaluates. The precedence of the logical operators can be a little bit tricky. The not operator has the highest precedence because it's a unary operator, meaning it has only one operand. And has a higher precedence than or, and this is true in all languages and in formal logic, similar to the multiply has a higher precedence than the addition in algebra. So this is kind of true everywhere in whatever language you're looking at. We also looked at the concept of true and false in C. It's tricky in C compared to other languages. The C language does not have a data type that represents true and false, so we use numeric values. 0 is false, and anything that's non-zero is true. We also looked at one of the pitfalls of using the assignment operator when you intended to use the relational operator equals. The assignment operator evaluates to the value that goes across the assignment, which very often will evaluate to something non-zero, which is true in C. So you have to really be careful to pronounce the assignment operator as gets or is assigned to or whatever you like, but not equals, because the relational operator equals is two equal signs. It's a very common bug in C. C programmers, all C programmers, will make that mistake at one time or other, and it can be very costly. We looked at the compound assignment operators, the plus gets, multiply gets, and there isn't any requirement that the language have these shortcuts. You could have done it in long form, but you're expected as C programmers to now use the compound assignment operator when it makes sense. So when you can use them, especially plus gets is a very common one when you're using accumulator variables. And we looked at the increment and decrement operators. This is the operator that adds one or subtracts one from a variable. Pre-increment and post-increment behave differently, and the difference is when does the increment happen. So a pre-increment will add one to the variable before anything else happens, and a post-increment will add one to the variable after everything else has happened. And it breaks the rules of precedence. That can make the increment and decrement operators a little bit tricky. You should use those operators sparingly. If you have very complex statements, you can make them more complex by mixing in pre- and post-increment and decrement operators. Remember that the cost of code is how long it takes someone else to figure it out. So our objective is to write code that other people can understand, and the first person who will benefit from that is you. Looking at your own code, you'll be able to understand what you did last week or last month. Okay, these new operators, you're expected to be using them in the next segments. I encourage you to go into the development environment and play with them until you're comfortable, so that when you have a problem to work on, you won't be sitting there thinking about, well, what did that operator do? You'll just have these in your vocabulary of the C language and be able to use them when you're solving more complicated problems. Okay, I'll see you in the next segment.